Hello everyone. Today's lesson is how can we apply the Pythagorean identities using trigonometry. Today we start with the do now. It says use the picture and substitute into the Pythagorean theorem using sine and cosine in place of x and y. So what we're going to do here is start with Pythagorean theorem. A squared plus b squared equals c squared. Then a little bit thicker. Okay, so we're using sine and cosine in place of x and y, or in this case, a and b. Remember that x and y are your legs. Sine and cosine are the legs. Doesn't matter where we put them, either into a or b. Those are interchangeable. I'm going to replace a with sine. So sine squared theta plus cosine squared theta equals 1 squared. Where did I get 1 from? That's our hypotenuse. Remember that the hypotenuse is always opposite the 90-degree angle. Okay, and all we do is simplify 1 squared, which is equivalent to 1. This is one of the most common trig identities. Sine squared theta plus cosine squared theta is equal to 1. Now, using this identity, we're going to find the value of the tangent of theta to the nearest hundredth if cosine of theta is equal to negative 0.7 and theta is in quadrant 2. Okay, so a whole lot of information here. Let's start with sine squared theta plus cosine squared theta equals 1. They're telling us right here cosine theta is negative 0.7, so we're going to plug in negative 0.7. Okay. And bring everything else down. All right, now we're going to square negative 0.7. That's going to give us 0.49. And now we're going to solve for sine. So subtract 0.49 from both sides. Now you might be asking yourself, why are we solving for sine if they ask us to find tangent? What's the relationship there? Well, think about that. Think about, is there a relationship between sine and tangent? Because we also have this little tidbit of information up here too. Okay, sine squared theta equals 0.51. We're going to take the square root of both sides because we want just the sine of theta. All right, and that is the square root of 51. We're going to leave that there for now. Square root of 0.51, excuse me. Okay, we need to find tangent. Let's remember that tangent of theta is equal to sine over cosine. Okay, sine over cosine. So we have both of those pieces. Sine of theta is radical 0.51. Cosine of theta is negative 0.7. Okay, and it says rounded to the nearest hundredth. So when we plug that in to GeoGebra, what you're going to wind up with is negative 1.02. Okay, and that's your answer. On to the next question here. Okay, given. So we have here secant of u is equal to negative 3/2 and the tangent of u is greater than 0. Find sine, cosine, and tangent using one of the Pythagorean identities. Okay, so let's talk about what Pythagorean identity we can use here. If you said sine squared plus cosine squared, you are correct. Okay, sine squared theta plus cosine squared theta equals 1. So we have secant. Remember what secant is. Secant of u equals negative 3/2. Remember that secant is the reciprocal of cosine. So therefore, we can rewrite this as 1 over cosine equals negative 3 over 2. Okay, we have cosine. We need cosine. What do? We just flip it. So if 1 over the cosine is equal to negative 3 halves, that means cosine is going to be equal to negative 2/3. Okay, literally just flip this. Take the reciprocal. Reciprocal. Okay, so we're going to plug that in to cosine. Bring sine squared. Instead of theta, we should change this to the little u's. Okay. Negative 2/3 squared equals 1. So sine squared theta plus, we're squaring this and we get 4/9 equals 1. Now just subtract 4/9 from both sides. Sine squared u equals 5/9. And we want to take the square root of both sides so that we just get sine. And we get radical 5 over 3. Now you want to ask yourself, is that positive or negative? Well, go back up here, tangent. They're telling us that tangent is greater than 0. So remember, all students take calculus. So if tangent is greater than 0, it means tangent is positive. It means that we're in the third quadrant. And in that third quadrant, sine is going to be negative. So therefore, sine is negative here, negative 5/3. Okay, so we found sine, we found cosine. Okay, remember cosine was negative 2/3. And now we want to find tangent. Now remember that tangent is equal to sine over cosine. So all we need to do is take sine, which is negative 5/3, negative radical 5, sorry, over 3, divided by cosine, which is negative 2/3. So negative radical 5 over 3 times 3 over 2. That cancels out, and we get negative radical 5 over 2. Okay. And should that be positive or negative? That should be a positive. Two negatives make a positive, and tangent is also in, it's telling us here that tangent is positive. Okay. So these are your most common Pythagorean identities, okay, right here. These are your most common. And then on the right-hand side, you see your variations. Notice how we get from one to the other. Literally here on the left, sine squared theta plus cosine squared theta equals 1. All you're doing is just subtracting cosine from both sides, and then that gives you the 1 minus cosine of theta over here. Okay, so that's really just how you're getting the variations. You're really just reorganizing or rewriting the equation to best suit your needs for the problem that you're doing. Okay, so the next couple questions I got from the previous Regents exams. So these are really something that you would see on your Regents. A lot of these are really just multiple choice questions. I haven't really seen any or come across any that were found in part 2s, 3s, and 4s. Most of them are found in the multiple choice section. Okay, so let's take a look at this one here. It says if theta is an acute angle and sine of theta equals 1/3, use the Pythagorean identity to find cosine of theta. So this information right here is telling us that it's going to be located in the first quadrant where everything is going to be positive. Okay, so again, most of these you're going to see that you can really just stick to the most common sine squared theta plus cosine squared theta equals 1. Okay, we have sine of theta is 1/3, so we're going to just pop that in 1/3, square it. Okay, 1/3 squared is going to give us 1/9. Subtract 1/9 from both sides. Okay, and that's going to be 8/9. All right, take the square root of both sides. Let me rewrite it up here. So once we take the square root of both sides, we get cosine of theta is equal to radical 8/3. And if we simplify that, again, just you want to express it in simplest radical form, we're going to get 2 radical 2/3. Okay. All right, here we have another one. If cosine of theta is equal to -3/4 and theta is in quadrant 3, find the sine of theta. So quadrant 3, again, if you need to just jot this down here on the side to guide you, all students take calculus. Quadrant 3, we know that tangent is the only positive value there. So we know that in this case, sine is going to have to be negative. Okay, so we'll start with sine squared theta plus cosine squared theta equals 1. Replace cosine with -3/4. We want to square that. Okay. -3 squared is 9. 4 squared is 16. Now we're going to subtract that from both sides. Sine squared theta equals -9/16. We want to take the square root of both sides. Sine of theta equals, okay. Oh, sorry, let me go back over here. This is 1 minus 9/16, which should be, that's going to be positive. Sorry, I made a little error here. So that's going to be 7/16. Okay, positive 7. Let me just rewrite this here so that it's not a mess. 7/16. So sine of theta is equal to radical 7/16. Radical 7/4. And because it's in the third quadrant, we know it needs to be negative. And that's your final answer for this question. I don't know why it does that. Okay. On to the next question. If sine squared of 32 degrees plus cosine squared of m equals 1, find m. Okay. So, sine squared of 32 degrees plus cosine squared of m equals 1. What do you think we should do here? So, plug into your calculator. Okay, bring up GeoGebra right now. I'll give you a second to open that up. And what I want you to do is find the sine of 32 degrees. Okay, so the sine of 32 degrees is 0.5299. I'm going to write this out for 4 digits, okay? And this needs to be squared. Plus cosine squared m equals 1. Okay, now we're going to square that. Okay, so on the next line, answer squared. That gives us 0.2 0.2808 plus cosine squared m equals 1. We're going to subtract 0.2808 from both sides. Cosine squared m equals. So now we're going to do 1 minus 0.2808, and we're going to get 0.7192. Okay, now what we want to do is take the square root of both sides to get the cosine of m. Okay, so we're going to take the square root of 0.7192. And that's going to give us 0.8480. Okay, now they're telling us to find m. They don't want us to find the cosine of m, they want us to find m. So what they're asking us for is to find the number of degrees. What we're going to do then is we're going to take 0.8480. Okay, we're going to plug that into the calculator. We're going to use cosine of -1. Cosine to the -1, 0.8480. Okay, hit enter. And what we get is 32. And it's going to be 0.00519 and so forth. But it should be 32 degrees. Okay. Now you might say to yourself, how come it's 32 degrees when that's what sine was? Sine was 32 degrees. Well, remember that sine and cosine a lot of times are well, think about like the sine of 60 degrees and the cosine of 30 degrees, how they kind of alternate on that chart that I had you fill out. Okay, sum it up. What are the trigonometric identities derived from? So basically, what did we start this with? Okay, we started with the Pythagorean theorem, a squared plus b squared equals c squared, and that's how we derive our trigonometric identities. All right, guys, I hope you found this helpful. If you need any help, you know how to reach me on Google Hangouts during my office hours. You can message me, text me, either on Hangouts or Remind, or email me if you need any help. Please make sure that you're doing the Delta Math assignments. Those are really important. Okay, and don't hesitate to reach out if you need any help. Bye, guys.